Hello guys, welcome to Sip Code, and today we are looking at not another cup of code, but we are looking at some interview questions. I want to talk all things Spring Boot, microservices, Java backend interview questions, how you can or how can you rather um, ace some of these questions when they do come up in your interview session with your panel for whatever job that you're looking for. So first things first, we'll be looking at the repository. So please do go to zipcode microservices interview. That is where all the questions are. And in this video, we'll be going through the interview questions and answers. So without wasting any of your time, let's jump right into it. But I would also like to request that if you're new in the channel, please do subscribe as we do all things Spring Boot backend and Angular front end tutorials. We do focus heavily on project-based tutorials where we showcase how a particular project or how a particular feature can be achieved. So the most recent release, it was the Jasper reports as well as implementing cache within your microservices architecture. So please do check out the channel and you will see a lot of Spring Boot features and projects with tutorials within the channel. So please do check that out. And if you are coming back, welcome back to Zipcode. Please do like and subscribe. We see a lot of people, about 85% of our viewers are not subscribed. So we would really appreciate it if you do click that subscribe button and you click on the notification button so that you stay tuned whenever we release a tutorial because we release any feature, any tutorial on a weekly basis. So we could be releasing something that you are struggling with or something that you want assistance with, and we'll be happy to assist. So with that being said, we will jump into the actual interview now and see what questions we have and how can you ace that particular interview that will be coming across in 2025. This is a microservices back-end focused interview question session. So please do stay tuned. And if you are a full stack developer, you're more than welcome, as it will come in very handy in terms of the back-end piece of the interview. So let's get right into it. And the first question will be, what is Spring Boot? So here they want to get your understanding of what Spring Boot is. And in a nutshell, Spring Boot is an open source Java-based framework. It enables quick, standalone, production-ready applications by allowing easy and quick configuration setup. So this setup is actually anything that you would want for the application to run can be an ease package within the application itself. So you get an application server that is provided to you, unless you have a scenario where you have your own designated application server. You can then partition that particular server and then deploy your artifacts or deploy your jar or WAR file into that particular application server. But in the instance of Spring Boot, you already have Tomcat that is embedded within the application, so you can just run it on the fly and it will basically perform the same way. And it's quick and easy configuration, which means whatever you want to define for your particular application, it's easily available and it's easily configurable. So things like your where you want your API port to point to, or what port you want to expose for your service. It's easily available within your application properties. You also have Spring Boot or Spring Framework features like your Spring Cloud, your Spring Data JPA, your Spring Security. If you want to make sure that your APIs are protected based on basic authentication, token-based authentication, SSL-based authentication, all of those come in and are configurable within the Spring Boot. So those configurations are made easy for you as a developer. So going further, you have third-party integrations and libraries all integrate easily with Spring Boot, and with these capabilities and features that are already made within this different module of Spring Boot with Spring Cloud, Spring Data JPA, Spring Security. All of these different libraries make it easy for you to integrate with your databases, implement security, implement or run your application on the application server that is already embedded and things like that. So this is the ease of development, and the framework makes it easily and accessible within your development space, and you can basically run the application without having an external application server, so that way it's production ready, and you can just release it on a particular server, and you can basically expose that particular API and have it easily accessible. And that is what we're talking about in here. So in the interview, please do share all of these, the features that you know about Spring Boot, particularly the features that you understand more deeper. Go into details on those so that they understand how extensive your knowledge of the fundamentals of Spring Boot is, and that is very handy. It gives the interviewer more confidence into what you can do and what you can bring to as a developer or as a backend developer that they are looking for. So they already know what projects they want you to be assigned to. So the more you go into details into different features, the easier it is for them to know that you can basically fit to what they expect. Because you're more likely to run into or the first thing that they will do is run you down the spec, the requirements, their stack, and things like that. So you would already know what type of project that you'll be dealing with. So when you go into this, go with that clear mind of these are the features that I've used, and these are I've used them in this project, and this was my role in that project as well. So that's very handy. This is an open question to understand how far you are with the fundamentals of Spring Boot and how well you understand the framework. And that's about it for the first question. Now, moving on to the next question is explain the microservices architecture. So you have different architectures within the, let's say, the system design or system architecture world. You have a monolithic architecture and you have a microservices architecture. And microservices architecture is an architectural pattern that structures an application as a collection of small, loosely coupled microservices that operate together to achieve a common domain objective. So in this instance, the domain objective is the bigger picture of the entire process flow. So the entire journey of the process, let's say from a user creating, let's say in a banking system, from a user creating a bank account, opening a new bank account, how do they register, how do they onboard, what accounts are available to them, which accounts can they create, and then from creating accounts, can they deposit, can they withdraw, can they transact, and things like that. So this is a common domain objective, and you will have microservices within that domain objective that will each microservice will cater for one particular objective, where you say a user, for a user to open an account, you have a registration microservice. So the registration microservice is responsible for creating accounts. There's no transactions there. You don't deposit, you don't withdraw, you don't do anything. Your sole responsibility in that microservice is to create an account. Once the account is created, then you will have, let's say, a transaction microservice that will then be responsible for you depositing, withdrawing, transferring amounts or the cash within your bank account and things like that. So these two microservices within this common domain objective, each one has a clear objective as to what they're intended for. They have a single isolated responsibility, and this is what you're trying to achieve in a microservices architecture. So the microservices design allows independent services to be added, removed, or upgraded without interfering with other applications in the architecture. So this means if someone is creating an account, the create account microservice, it can be added, removed, and upgraded without interfering with the transaction microservice. So the transaction microservice is the one that is responsible for you depositing, withdrawing, and all of those things. So the one microservice can be removed without impacting the other. So even if one microservice is down, it shouldn't impact the other microservice because all these microservices have their own intended objectives and they have an isolated responsibility. That is the flexibility that we want in a microservice architecture. So if you also want to go deeper into a monolith architecture, you can also do that so that you're giving construct yeah contrasting views. Yes. So that they are able to get your understanding that in a monolithic environment or architecture, you would have all of these services within one application, and you wouldn't be able to distinguish which service does what because they are all packaged as one. So if one of the APIs within that service is broken, it means that the entire service is broken. So if let's say the deposit API fails or is broken, it means the create account service will also be broken because everything is packaged into one monolith. Whereas in a microservice architecture, you wouldn't have that situation. If the deposit API is broken, the create account microservice will still be up and running. So clients will still be able to onboard and create accounts, even though they might not be able to deposit funds into those accounts. But that will be a different flow that will be addressed by a different resolution structure. You debug, you figure out where the issue is, and then you address the issue at that particular level. So this is what the microservice architecture offers in terms of the difference with the monolith. So now let's move on to the third question. What is object-oriented programming? This comes up a lot in a lot of interviews. They will never not ask you this one because they want to understand which design principles do you understand, or what do you understand about object-oriented programming. So they want to know if you understand the principles that drive object-oriented programming. So this is a programming paradigm that focuses on using objects to represent and manipulate data. So OOP encapsulates data within objects. So these objects consist of attributes which can be variable as well as behavior, which is methods that actually perform some process within these variables or within the data. And then it has a number of ways to perform highly scalable, maintainable, modular code, and these are abstraction, inheritance, encapsulation, and polymorphism. So the more you share in this space of object-oriented programming, abstraction, share that. What are we abstracting? We want to hide the data's accessibility. That's why you have your object, you have variables, and you have access modifiers for those. So that is actually encapsulation, but abstraction is you want to abstract a responsibility from the concrete class into a separate service or business logic where it can be shared across multiple concrete classes or concrete implementations or common processes or common code base. That is where you abstract and move some of the code base or business logic into one common area, and you can be shared across multiple implementations. And then you have inheritance, where you have common attributes that need to be shared across different requirements. Let's say in terms of shapes, you can have like an interface of shape, and then that particular shape can implement different things. Or like a car, when you say car start, a car can start because it has an engine, and a truck can start because it has an engine. But in terms of like a shape which doesn't have an engine, it can't implement a car interface and things like that. So those implementations and abstractions and encapsulations, please do share as much as you can for all of these four object-oriented programming principles. So abstraction, inheritance, encapsulation, and polymorphism. So these you need to go into details, share what you know, and share how far you understand. They want to know the base, they want to know the fundamentals of all these, and they will ask you examples as to which is which, and you would need to apply that accordingly. And going forward into the fourth question, what are solid principles? So now going further, this is to get your understanding of the fundamentals of a system architecture or system design. So let's go into solid principles. So this is a set of 5 design principles that assist developers to write clean, maintainable, highly scalable, as well as flexible code. So in this instance, you have SOLID stands for single responsibility, open close principle, list of substitution, yeah, interface segregation, and dependency inversion or dependency injection. So these 5 design principles are there to make sure that developers write clean code, highly maintainable, highly scalable, and flexible code. So as the more you go into details into this as to what are they for and when to use one and when not to use one, like single responsibility, you want to make sure that any class that you have, it has one single responsibility, the same as in a microservices architecture. A microservice should have a single responsibility. It achieves this particular piece of the actual domain objective, and that's what it does. It creates user accounts, and that's what it does. It doesn't transact, it doesn't do anything else. It's just there to create or register users, and that's it. And then if you go to open close is a class is open for modification but closed for extension, things like that. So you also have list of substitution, you have interface segregation, and you have dependency invasion. So all of these are principles that are available to us as developers so that we can write code that is readable by other developers, and we can basically be able to maintain it going forward. And if there's any issues with the code, we can easily add or remove features based on a particular issue that we might come across, a new feature that we'll need to add. So these are the principles that are available to us. And then going on to the next one is, what is event-driven design? So this is now talking to the types of transaction or processing that will be happening within your particular project or within your particular service. So event-driven design is a programming paradigm that implements the execution of a process based on events such as user input or certain communication towards the system or service. So the application can respond to the input or message in a certain behavior to achieve the intended goal. So you have different communication channels that can basically hit or communicate with your system or your service. In this case, you can have Kafka, you can have queues, you can have an API. So these are some of the, let's say maybe some of the mechanisms available for event-driven design. In terms of API, you can have like your webhooks and things like that. So these are communication channels that can be implemented to make sure that if a particular event is triggered, then this particular service should process this particular event in this manner. So there's a user that is trying to create an account within our banking system. So once we get that user registration and the user hits submit from the front end, that goes into the back end, or it goes into a queue, or it goes into a Kafka topic, and the microservice can then listen to the Kafka topic or listen to the queue, and then consume the messages from the queue or the topic, or from the webhook based on a particular process. And all of these are communication channels that are available within the event-driven design. So the more you share about these, the more they know that you understand what it means to implement a event-driven design and how each process needs to go. So as you design this process, the journey of different events, and different communications within the service, or how the service is going to start the journey up until the data is persisted into the database and the user receives their feedback, where they are going to receive a message from an API, or they will receive a push notification, or they'll receive an email, or they'll receive a text message. All of those will be response mechanisms after your event has been processed, whether it failed, whether it succeeded, and things like that. So go into details as to the implementation that you can use within event-driven design, and how you've used it before, and which project and what role you played within that space. So that's about it for this particular question. Let's move into the next one. What is declarative programming? So in this instance, this is a method to abstract the control flow for logic required for software to perform an action. So again, it's an abstraction of the control flow for the logic. So it's actually, instead, it involves stating what the task or desired outcome is. So this hides the internal complexities to perform a set task by just specifying what we want, and the system executes it. So if you look at, let's say, databases, for example, you go to, let's say, MySQL, you say select a star from table, blah, from database, schema, table, blah, 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 and I want to see all accounts, or from the accounts table, select star from accounts table, for example. We don't care how the database goes and interprets that particular command or statement. We just want to select everything from the accounts table, and the database is going to go retrieve all those records and bring them back. We do not know how it does behind the scenes. Well, as a developer, you can always go into and check and debug and all of these things to see how everything is done under the hood. But in essence, what we're saying is we can basically write a statement verbatim, and the process flow is abstract to us or from us, that we don't see the underlying implementation. We only see the results, and we are fine with getting the results that we want. We don't need to stress about the internal complexities, and that is what we're talking about in this instance. So let's move into the next one, and this is what is test-driven design. And again, this is system architecture, so you would want to go into these conversations and go deeper into your understanding of the fundamentals of all of these design principles. So this is a development methodology in which a concept of software is first run under automated tests before developing the code to perform the set task. So a number of test cases are created as a desired result of the feature, and code is then created to pass this series of tests to be considered ready. So here it's like you are coding based on a expected result. So you already have the test cases laid out as to what needs to pass for this feature to be ready, and then you go into the code and then write the code base that will fulfill those particular test cases, and all those test cases would need to pass before we can regard your code as ready for release or ready for QA and things like that. So in this instance, you start with testing the feature, and then you go into writing the code, which will then be, the code will then be scrutinized by the test cases, and if all the test cases pass, then the code is ready to go to the different environments that you have. And that's basically how you implement the test-driven design. So this one is pretty much straightforward, and let's go into the next one. So what is the difference between Spring Actuator and Spring Boot Admin? So this is basically quite similar, but you will see in just a few how they differ. So Spring Actuator is a module made available to easily monitor a single Spring application. Pay attention, monitor a single Spring application. So Spring Actuator is, is embedded within a single Spring microservice. So a Spring Actuator exists within a single Spring application. And then this is specified within a particular Spring service. So that particular microservice will have a Spring Actuator specified within it. So it's like it's embedded within the microservice itself. And then on the other hand, Spring Admin Console is a standalone Spring application. So it's like Spring Admin Console is a Spring microservice itself, and it is used to monitor Spring microservices. So a Spring Admin Console is a Spring application that monitors other Spring microservices, and all the microservices within the domain can register themselves, so the admin console can monitor them utilizing the Spring Actuator definitions they have. So a Spring Actuator is embedded within a Spring microservice. Then a Spring Admin Console then monitors those Spring microservices using the Spring actuators that all these services have. So if I have the create account microservice and the transaction microservice. So these are two microservices, and each microservice within itself has a Spring actuator. And then the Spring Admin Console monitors both of these microservices, and it uses the Spring actuators that each of them have to monitor them. So that is the difference between a Spring Actuator and a Spring Admin Console. So the Admin Console is a standalone that watches all of the Spring actuators that are running for all the microservices, and then it uses the actuators across all these microservices to monitor the state of the service, if it's up or if it's down, and then it can send alerts if you need them to, let's say, via email to say accounts microservices down. It can notify whoever needs to be aware or alerted as to services failure, services down, and things like that. And also you can then go into the log levels for the different microservices and see what the issues are based on that particular logging message that you would see over there. So this is the the difference between Spring Actuator and Spring Admin Console. So that one is done, and let's move into the next one. So how can you use Spring Config Server in Spring Microservices Architecture? So the Spring Cloud Config Server allows applications within a microservice architecture to subscribe to the config server as clients, so they can get applications properties or configs from the server. So the server is responsible for issuing the application properties or application config to all of these different microservices on the fly, and it's basically the application properties are remote, the application configs are remote, and you can basically update them remotely and just bounce the config server and then bounce the service that is that you want to pick up that particular config or the new configs that you're introducing, and will take it from there. So the cloud config is responsible for hosting the different properties for the different client applications and serves them remotely. So config server makes the properties available via HTTP to the individual subscribers. So if you have two microservices, both these microservices will subscribe to the config server, and the config server is responsible to offer or issue the application properties to both these services respectively and independently in isolation. So the create account microservice will have its configs issued to it independently, and then the transaction microservice will have its own config issued to it in isolation. But both of these are being served by the config server. So the host of the configs is the config server itself, and then it makes the configs available to the two microservices respectively, or all the microservices within the domain respectively. So that's what the Cloud Config Server offers to us within a microservices architecture. And then moving forward, it's explain what Spring Eureka Service Discovery is. So now you're getting to the nitty-gritties of the Spring features. This is a standalone registry responsible for managing other microservices within the architecture. It facilitates dynamic communication between microservices, enables services to easily discover each other and establish seamless communication. So the registry is also responsible for load balancing to optimize performance. So this is where you want to have highly scalable, highly performing microservices. So the load balancing to optimize the performance is very critical in an enterprise application. So having the service registry that will be responsible to watch how much traffic, how much load we have coming into our service, and it can distribute that particular load across our microservices or across our containers within our containerized environment via your Docker, Kubernetes, and things like that. So this is what is made available by Spring to make sure that we have highly performing microservices and we have enterprise ready scalable applications. And that's about it for this particular one. Let's then move on to the next one. How is Spring Cloud Gateway important in a microservices architecture? And again, these are Spring Boot features that they will most likely ask you. So the more that you understand about them, the more that you understand the fundamentals about them, the more they can have faith and trust in you, that you know what you're talking about. You've been exposed into this space. You've used these. You have practical examples where you've implemented these particular features, and you can basically be the guy that is suitable for this particular role. So let's get right into it. How is Spring Cloud Gateway important in a microservices architecture? So it is an API gateway that serves as a single entry point to all microservices. So the API gateway is responsible for all calls to our microservices. This is the entry point, and it abstracts the need for clients to know addresses to your microservices, but only have a single entry point, and based on the request, the gateway will route the request to the intended microservice. Note the gateway can contact the Eureka service discovery to get the actual microservice to serve the request. So the Eureka service discovery and the API gateway, both of them, they can communicate with each other to figure out I have this particular request, which service can be able to fulfill this particular request for me, and the service discovery will be able to say, oh, this is the request that you have, and it has A, B, C, and that maps to this particular microservice. Therefore, this request can be fulfilled by this particular microservice, and the actual microservice will then take responsibility of that particular request and service that particular process, and then respond based on that particular request. So the entry point is the API gateway, and the API gateway will then say service discovery, which service is going to be able to fulfill this particular request, and then the service discovery will be able to say, okay, this is the service that will take that will handle this request, and you will have different service keys as you define these. And if you want to see this in action, I would recommend that you please do watch our tutorials within the channel. We do have extensive tutorials with all of these different features, and you will see real world code. And within our repository on GitHub, please do check those out. We do have most of these features already in code, and you can just pull the microservices, put them to the test, run them, and you will see all of these running at play with actual live or real world examples. So you will have your API gateway and you will have your service discovery, and you can basically hit these APIs via the API gateway and see how all of these come together and speak to each other. And the more that you can share and basically take them through a journey of this is a request that is submitted from one API endpoint, and that endpoint is exposed via the API gateway. And then from the API gateway, this is the key that was defined within the API request. That key maps into the service registry to the actual microservice, and that particular microservice is able to then say this request will be fulfilled by this particular microservice endpoint, and then it will basically process that, create an account or transact, deposit, withdraw, whatever request that was submitted, and the particular microservice will serve that particular request and then feedback with that particular response. And that is the level of detail that you need to go into in terms of the process flow as to how far do you understand or how deep do you understand all of these particular features. And that's about it for the API gateway. Let's go into the next question. And we almost there, we almost done. The one thing that I would request is that please do subscribe, please do like, please do hit the notification bell so that you are alerted each time we make an upload. And this is one tutorial which is going to come in very handy, or one dEVtALK that's going to come in very handy in a lot of Spring developers, Java Spring developers, acing some of these questions when they get to interviews, and they do not have to shake when they hear some of these questions asked. So please do stay tuned as we'll be releasing more and more tutorials. There's a lot coming this year, so please do stay tuned. And let's go back into the question. So in Spring Security, which authentication mechanism can be implemented and which one are you comfortable with? So now this is a question that is posed to you as to when it comes to Spring Security, or let's say microservices security, what is it that you know about it? Which authentication have you used? What have you been exposed to? Now in this instance, you will go into as much as you can. So security mechanism can vary based on requirements. You have token-based authentication, which is JWT. You have basic auth, which is username and password. You have LDAP, which is Active Directory authentication. You have SSL-based authentication. And these ensure that we have control over access to the system and what users are able to perform within the system. So this is it's not only authentication, and it is also authorization in terms of if we have user that can access the application, what parts of the application can they access, and which transactions can they perform within the system itself. So this is now role-based access control. So the more you share in terms of the security, the more they will understand that, okay, you know what you're dealing with. That token-based authentication, you have a user that will have a particular key or a key, a value, or whatever the case may be, and then they submit those particular keys or the particular secret and the passcode or the PIN or whatever, and then they will basically get a token. That token can then make sure that we have all the details within that particular session for this particular user, and we know that all of the roles or the authorities that this particular user has are basically within that token, and we can basically check the token to make sure that can the user transact here, yes or no? Can the user transact here, yes or no? So based on the roles that are already available within the token, we can basically give the users access to certain piece of the system and block them from accessing different parts of the system. So that's basically now the authentication and authorization. And basically, in this particular case, you would give them a real-world example where you've implemented one or any of these particular authentication mechanisms with the different authorization if you got to the authorization piece of this particular of the security feature. So that's basically what we want to understand in terms of your level of API security. So let's go into the next one. And in this particular one, they would say, how can you implement ACID principles in relational databases? So here it's basically just a database question to understand what's your understanding when it comes to relational databases. And these principles are the same as OOP, solid principles in databases. You also have certain principles that you need to know, and those ACID principles is part of them. So this is a set of principles that guarantee data integrity, consistency, reliability, as well as durability. So this ensures that all database transactions adhere to the defined rules, constraints, and requirements. So the database structure that you have, every transaction that comes through that or comes to the database, it must adhere to all the constraints that you have, all the foreign keys, all the non-nulls, all the relationships that are established within that particular database, all the indexes. So you want to make sure that the structure and the integrity of the data remains the same. So the state of the database should remain the same before any transaction and after the transaction. So anything that happens there, it must always conform and adhere to the rules, constraints, and requirements. So ACID stands for atomicity, consistency, isolation, durability. So you have atomicity. Atomicity is essentially every transaction that goes to the database is either it is regarded as a single unit of work. Within a transaction you can have multiple queries, a select, a update, a create, a whatever query that is within the transaction. a, all of those queries should and must succeed, or they must run through successfully for the transaction to be regarded as successful. So if any of the queries within a transaction fail, the entire transaction is going to be rolled back. So let's say you have a select, update, and a create within one transaction. So if the update within that transaction, if the update query fails within that transaction, the entire transaction will fail, which means the create will not happen, the update will not happen, the select will not happen. It will be like the database was not even touched. So that is atomicity. Atomicity is everything within the transaction is like the transaction is the wrapper of all the queries that are going to happen inside it. So everything that happens inside the transaction must be successful, otherwise the entire transaction fails. That's atomicity. So consistency, it's adhering to all the rules that are there so that everything is consistent. So if there are constraints, all the queries within the transaction must follow the constraints accordingly, follow the rules accordingly, follow the requirements of the database as defined when you were designing the database accordingly. So the state of the database before the transaction, after the database should remain the same. That's why we make sure that the data integrity is kept as per normal or as per usual. And then isolation is for if if you have multiple transactions running at the same time, no transaction impacts the other. So it's all transactions are executed independently and isolation from one another. They don't care whether there's a transaction running now. They don't care. And any and every transaction will run independently without any interference by another transaction. And then durability is once the data is persisted or rollback, we know that everything is once it's committed, it's persisted to the database, and even in a situation of system failure, the server shutdown, or network issues, if a transaction has been committed, it's persisted, and the data is there based on the required rules, constraints, and requirements. So that's basically what we talk about with durability. So if the transaction failed, well, the transaction will just roll back and nothing will be persisted to the database. But if it was committed, then everything ran through successfully and it's going to be stored and persisted into the database. And that is what durability is all about. And you will need to go into details as to the ACID principles according to your understanding, and this is where they get to know that you understand the fundamentals. So now let's move on to the next question, and that is how does Spring make use of? So this is supposed to be make use of object relational mapping, and object relational mapping is essentially so in Spring, Spring utilizes JPA and or Hibernate to implement the object relational mapping design pattern. So for relational database interactions, sorry about that. So this offers the capability to transact with the relational database for any CRUD operations. So all our database transactions, they will be using the object relational mapping, and the object relational mapping is a phenomenon from the object or it's a design pattern for object-oriented languages where the objects can interact with the database via the Java persistent API or Hibernate. And this is where we basically abstract the database communication where Spring can just handle the code and JPA is then responsible or Hibernate is then responsible for the database interactions where it will submit the queries that we want to the database and basically retrieve any of the feedback from the database according to what we get. So with ORM is where you basically utilize your Spring Data JPA to interact with your database and basically perform these CRUD operations. You create, you read, you update, you delete in the database, and that's made available via the Spring Data JPA. So this is like a different way of asking you about the Spring Data JPA module. So you would have to be able to pick that up and basically share your understanding of that particular module or feature of Spring. So I think this is the last one. Yeah, I think this is the last one. And the last question is, how would you ensure a highly scalable microservice that is highly performing or with high performance? And here you implement containerization within the system architecture to allow for ease of auto-scaling of your microservices based on traffic or load demand. So as we've mentioned, you have API gateway, you have service discovery, and on top of that, you also have Docker is one of the container management toolkits we can utilize to create images for our microservices, and then we can basically release those and run them via Kubernetes to auto-scale all of these particular containers that we have for our different microservices within our domain. So that is basically, in a nutshell, how you could implement highly scalable, highly performing microservices and within your microservices architecture. So I would say this is the end of the interview, and I've shared as much as I can on these particular 15 interview Java Spring Boot interview questions for 2025 that will most likely you will come across these questions. And if you do, and when you do, actually, not even if you do, when you do, be ready, be prepared. If you want the slide, please do comment in the section down below that you would like the slide so that I can share with you the questions and the answers, as these answers are not in the repository. In our Git repository, we only have the questions, but if you also want the answers, I can share this slide because it's a Google slide. I'll just share the link with you, and make it available so that you can basically go through it and prepare for your interviews. And if you also have maybe practice questions that you want clarity on, you want them simplified so that you can, when they are asked in an interview panel, you can basically go straight into the point as to what they want without beating around the bush and going all over the show without a clear answer. So if you have those practice questions, please do share them with us, and we can basically go through them together, and then you can basically, I think we can create a live for it where we can go through them with you, and we can basically share some of the practical examples of how those can be implemented, and you can basically go to an interview with confidence. And I think this is where I would end the video. I don't want it to be too long. I already know that it's super long at this point, but I hope it comes in very handy and it assists you to ace your interview and hopefully get that particular offer you're looking for and start earning some big bucks with your Spring development journey. So for now, guys, until next time, please do like and subscribe, hit the notification bell. For now, cheers.